Hi guys, this is the quiz for the first week of class, week 1-0. The first question says, exprime 11 in binary. Now, the way to calculate a number in binary is you can start off slow to first get a grasp of it. So it's the methodology is only using zeros and ones and continuing in each place from there. So the first number 0 would be equal to 0. The second number, which is 1, so 1 would be equal to 1, and now that you've filled up the ones place, you continue. So now instead of going to 2 as we would do normally in base 10, we start the tens place. So that would be filled up as 1 0. 0 is equal to 0. 1 is equal to 1. But now this is where it changes. 2 is equal to 10 or 1 0 in binary code. And you can continue to get a grasp. You can go 1 1. Now that that's filled, you go to 4 equals 1 0 0. You can continue 5 equals 1 0 1. 6 equals 1 1 0. 7 equals 1 1 1. And so on and so forth. This question is asking for 11, so if you want, you could just continue and find the answer. It's a little less efficient. You wouldn't have time if you were writing a test to do it that way. But if you want, you can. 9 equals 1 0 0 1. 10 equals 1 0 0 1 0 1 0. And 11 equals 1 0 1 1. That's the answer. Perfect, done. It's slow. If you want to know the methodology of solving binary, you're able to do a very simple, quick method, which is each place defines a point. Each place defines a number of base 2 to the power of something. So 2 to the power of 0 is the first one. 2 to the power of 1 is the tens place. 2 to the power, not times, to the power 2 to the power of 2 is the hundreds place, and 2 to the power of 3 is the thousands place. And now we can solve for our number much faster. If the number is included in the calculation, this number will be 1. If it's not included, this number will be 0. So we know that 2 to the 0 in our code goes up to 1. We know that in base 10, we know that 2 to the 1 goes up in base 10 to 2. And we know that 2 to the 2 in base 10 goes up to 4. And we know that 2 to the 3 in base 10 is 8. So, how do we solve for 11? Simple mathematics. You see, all you have to do is count to 11. So, 8 is the biggest number, that's a 1. 2 and 1 will add up to 3. 8 plus 3 is 11. So we have 11 here. 1 1 1, 0, it's backwards. So read it from down to top. The number is, as we got before, 1, 0, 1, 1. Simple. Very simple. What's nice is that the number 11 itself is also in binary code, so I figured as some extra practice, you can try and convert it the other way around. What is 1, 1 in base 10? 1, 1, let's do our new methodology. Okay. What is 1, 1 in base 10? 1, 1 from binary. Okay, so what we have to do is we have to take the first number, which is the ones place. We do 2 to the power of 0 equals 1. 2 to the power of 1 equals 1. Add those two numbers up. This equals, as we saw before, this equals 1, and this equals 2. So, very basic arithmetic, but the answer is 1 plus 2 equals 3. 1 plus 2 equals 3. And that's for extra practice. Come up with your own numbers. That's question number 1. Question number 2 is, what is the word 01001010, etc., etc.? So, we learned in class about ASCII. So, here, let's just start a new line. Question number 2. In class we learned about ASCII, and that's the code for everything that you click on the keyboard. The word ASCII has its own code. Everything that you type in the keyboard is encoded, embedded into the 8 bits of data, and that's 8 bits means 8 levels, 8 powers are included in the calculation. ASCII goes that A is equal to 65. Capital, make sure they're all capital. Capital Z is equal to 90. If you want, so to make it easier, let's put all the, make sure it's capital, put all the letters in between. E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Oh, we already have Z. So each number is equal to another, is equal to a code in binary code which encrypts the data. So what are the words we're trying to look for? The letters are 0, 1, 0, 0, 1, 0, 1, 0. I have it here on the side, but you can see that it's the same number. That's the first number. Let's take it number by number. Okay, so as we saw before, the method that we used, this is where it comes in handy, because we don't have time to go and break down 65 plus letters. So what do we have? We have in the tens place, so 2 to the power of 2 to the power of 1 plus 2 to the power of 3 plus 2 to the power of 1, 2 to the power of 3, and 2 to the power of 6. Right? Right. 2 to the power of 6. So, we know that 2 to the power of 1 is 2 plus 2 to the power of 3 is 8. 2 to the power of 6 is 16, 32, 64. 64. So that number right there is 74. Equals 74. Great. We have our first letter. What is 74? Start here. 66, 67, 68, 69, 70, 71, 72, 73, 74. We have the letter J. Take that letter J, put it to the bank. That's our first letter. So is J. So now we have the letter J. We can go on to the next one. What's the next one? 0, 1, 0, 0, 1, 1, 1, 1. Okay. We can do this manually. So 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 to the power of 0, 1, 2, 2 to the power of 3. Now we're rolling. 2 to the power of 3. And the last one is 2 to the power of 6, of course. Plus 2 to the power of 6. We have 1 plus 2 plus 4 plus 8 plus 64. Okay. We know that that equals to 64, 79. 79. Okay. Beautiful. Find 79. We know already that 74 is J, so we can just go from J. 74, 75, 76, 77, 78, 79. We got the number, the letter. 79 equals O. So now we have J and O. The next one, let's go to the next one, is 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0. Right? Let's just double check. Yeah. Okay. So, let's try and play that game. What is this letter? So, we have our 64. We see that already. Right there. And then, let's just get the value of the second one. First number is 1, 1, 2, 4, 8. 64 plus 8. Plus 8. And I just counted quickly to save some time. That number is 72. Okay, we have the number 72. 72 is 2 letters behind J, is I, H, H. We have H. Perfect. J, O, H. I wonder what the word is going to be. Our teacher's name is John, so maybe it's going to be an N. but let's not get ahead of ourselves. Let's solve for the last letter. 0, 1, 0, 0, 1, 1, 1, 0. Okay. If we solve for that one, it is we have 2 to the power 2 plus 2 to the power 3 plus 2 to the power of 1. Forgot to put in 2 to the power of 1, 2 to the power of 1 plus 2 to the power of 6. 2 plus 2 to the power of 6. Beautiful. So we have 2, 4, 8. That's 14 plus 64, 78. Okay, equals 78. What's 78? We have 79 already, which is O. So one letter before that is 78, which is N. 78 equals N. What is our word? N H O J, or John. Now, if you want, you can do your own name, your own word. It could be an extra little exercise. It's fun. But for now, let's move on to question number 3. Question number 3. Question number 3. Oh, keep doing that. Question number 3 is, what is 12 in base 3? Okay. So to solve for 12 in base 3, we do a similar methodology if we want. First, we can just solve for it, but we can do the same thing. But first, let's solve for finding it. 12 in base 3 equals equals 3 now, because we're base 3. 3 to the power of 0 plus 3 to the power of 1 plus 3 to the power of 2. Okay, 3 to the power of, we're doing 12, so we have 3, 9. So we have 9 is the hundreds place, 1. We have 3 is the tens place, 1. And 3 is the zeros place, 0. 110 is the answer. Yeah, that's just straight up the answer. We can also, we're very fortunate that the number 12 itself is a base 3 number, so we can try and figure out what that is. We don't have to. Anyways, that's the answer to that one. Question number 4 is coming up with our own personalized homemade algorithm. Let's see what we got. So, question number 4, create an algorithm. How many empty bottles? Easy question. How many empty bottles are in your fridge? Okay. Empty bottles. Whoa. How many empty bottles are in your fridge? Okay. So you can always do the easiest algorithm to start off with. If you want, that could be the answer. How many empty bottles in your fridge? Start off, n equals 0. N equals 0 means that you have 0 bottles. And that's where your starting point is. You always want to create an origin so you know where you're beginning with. N equals 0. Then you just create a constraint. For every empty bottle, set n to n plus 1. Now, what this is going to do is it's going to loop itself. So you start off n equals 0. If you find a bottle that is empty, bang, your counter will go from n equals 0 to n plus 1. Then you're going to restart. And it's going to keep going. It's going to keep counting to the next one. And that'll get it straight. But if you want a more efficient way of creating an answer, and let's say we take it to real life, how would you be able to, without spending too much time, build in a system where you have a built-in counter algorithm creator? So, well, I thought of this algorithm which pertains to real life. You have bottles in a case. So every time that you finish a bottle, you put the bottle in the case in the fridge. So every time you finish a bottle, you put a bottle in the case. Let's say a case has 12 bottles. Okay? So if a case has 12 bottles, this is what you do. You say, how many full cases are in the fridge, and then for every non-full case, you count the bottles inside of it. So, start off, set n equal to 0. For every full case, set n equal to n plus 12. For every, if you are left with a case that is not full, set n equal to n plus 1 and take out 1 bottle. And there you go. What this will do is every single time you have a full case, you'll go through, as we saw in the video, a sort of loop. Every time that you have a full case, n plus 12, n plus 12, n plus 12, n plus 12. Let's say you have 3 cases, then you'll end up with 36, 3 full cases. On the 4th case that, let's say, has 5 inside of it, you'll count 36, then you'll add one, but every time you add one, you take out a bottle, from the extra case. Every time you take out a bottle, you're going to add one to the next number, and in that case, we'll then have one less bottle. So you have 36, let's say you have 5 in the fourth case, you'll have 36 plus 1, 37. Then you'll have 4 bottles now in that case. 36 plus 1, then you'll have 38, 39, 40, 41. And you'll get your answer in a much more efficient way than sitting there and counting 1, 2, 3 until you get to 41. Thank you for listening to this video. I hope it was informative and you learned a lot.